Good evening, my dear friends. Today we will study the module 4. So, in module 4, we will be finding the deflection and the slope. So, this deflection and slope can be determined by Castiglianos method. Or by strain energy method, and then by unit load method or virtual work method. Unit load method or virtual work method. So we can find out the deflection and the slope by Castiglianos method, strain energy method and unit load method. Regarding the theory part of this module, I will be uploading that in the WhatsApp. So in Castiglianos method, the deflection delta C, so delta A is given by integration 0 to L m by EI into delta m by delta p, the partial differentiation dx. This is by Castiglianos method. The same way, the delta A for a unit load is given by 0 to L m by EI into m dx. So this is by the unit load method. So in the same way, in a strain energy method, here it is considered strain energy is equal to the work done, and then the strain energy is given by 0 to L m square by 2 EI dx. The workload is given by half into P into delta. Let us take it as delta A. So by equating these two, we get the deflection required. So today we will try to solve one problem by all the three methods. Let us take a problem, and we have to remember one thing. In a strain energy method, we have a limit. We can find out the deflection only below the load, point load, and this method can be applied only when there is a single point load acting on the member. So that we have to remember for a strain energy method. I will repeat it. So this method can be applied only when there is a single point load acting on a member. So today we will consider one problem. So let us take this one. A and B, a point load acting at a center P. Let us take the span of the beam AB as L. Let us take that P is acting at the center. So we can find out the deflection at C where the point load is acting. So to find out that, before getting the deflection, first we have to calculate the reaction of a member. So when I take sigma MA is equal to 0, I can write P into L by 2, load into distance, is equal to reaction RB and then RA is equal to reaction into perpendicular distance. Therefore, RB is equal to P by 2. So we can write RA plus RB is equal to total load, from which we get RA is equal to P by 2. So once we calculate the reactions, once we are done with that, the next step is to find out the moment. So moment X. So let us consider, because it is a symmetric, we will consider only half portion. Let us consider a section XX from support EA. So we have to find out moment at X. So we have only one reaction here. So we get Mx is equal to RA into the perpendicular distance X, which is equal to Px by 2. So this is the moment. So once we have calculated the moment, let us take one by one the different methods. First we will take Castiglianos method. Castiglianos method. So in this method we have a formula. So we'll consider the deflection and then we'll calculate. So because of symmetric 2 times 0 L by 2 we will take m by EI into delta m by delta p dx. So let us calculate for this. So delta C is equal to 2 times 0 to L by 2. The moment is, we have calculated the moment, that is Px by 2, m by Ei we have, so this is m by Ei. So what is that? Partial differentiation with respect to P. Differentiation of m, that is Px by 2 dx. So here we have to integrate with respect to x. So I will take these two terms outside. 2p by 2ei integration 0 to L by 2. The partial differentiation here will be x by 2. This x we have left. So that is x dx. So that is p by 2ei integration of x square dx. X square dx. So we know the integration of x raised to n. X raised to n integration is x raised to n plus 1 divided by n plus 1. So we will apply that here also. So what happens? Here we get p by 2ei. X square is x cube divided by 3 with limits. So that will be equal to p by 2 6ei. In place of x, substitute the values upper limit minus lower limit. We get PL cube by 2 cube is 8. 8 6 are 48. So 48 EI. Therefore deflection at C is equal to PL cube by 48 EI. This is Castiglianos method. So once we calculate the deflection by Castiglianos method, now we will take the same thing by strain energy method. So the strain energy method is like this. U is equal to integration 0L m square by 2ei dx. So because of symmetric, we will take 2 times 0 to L by 2. M square is p square x square by 4 into 1 by 2ei dx. So keeping only the x term, we will take all the constant terms outside. It will be p square by 4ei integration 0 to L by 2 x square dx. So integration of x square is x cube by 3. So this will be like this, x cube by 3 0 to L by 2. That is p square by 12 ei. In place of x, we have to substitute upper limit by lower limit. So we get p square by 12 ei into L cube by 8, which is equal to p square L cube by 12 8s are 96 ei. So this is strain energy. We know that energy is equal to work done, which means that p square L cube by 96 ei is equal to half into p into delta C. So from this we have to calculate delta C. So from this we get delta C is equal to PL cube by 48 EI. So you can see here delta C is equal to PL cube by 48, and even by Castiglianos method we have got the same thing. So this is how we have to calculate by both the method. Let us take the third method, that is unit load method. In unit load method, what we have to do is, replace the load by 1 kilonewton. Unit means 1. So replace P by 1 kilonewton. Let us take this as C. So from this we get RA is equal to RB is equal to 1 by 2. Right? 1 by 2 kilonewton. Let us take a section here XX and let this distance be X. So because of this 1 kilonewton, what will be the moment? Let us denote it by small m. Mx is equal to Ra into X, which is X by 2. So unit load method, we have a formula for deflection. Delta C is equal to 0 L mx into mx by EI dx. So because of symmetric, we will take delta C is equal to 2 times 0 to L by 2. We have calculated already m, which is Px by 2 into, let us take that EI outside, and then because of unit load, it is X by 2. Now take all the constant terms outside. P divided by 2 EI 0 L by 2 x square dx, which is equal to P by 2 EI, x square is x cube by 3, 0 L by 2. So P by 6 EI, x cube is L cube by 8 minus 0. So this will be PL cube by 48 EI. So delta C is equal to PL cube by 48 EI. This is how we have to solve by all the 3 methods. So we will take one more problem after this video. One more video we will have for that. Thank you.